Okay, welcome back, guys. So, as I was saying, um, so for this aspect, this first two collectively, they are known as the schematic design. So, for schematic design in our open source IC design tool, we're just going to be doing those two here. That's for the schematic capture and for the electrical simulations. So, the electrical simulations means your AC analysis, your DC, and every other. It could be noise analysis. Those, I know those ones are pretty advanced. We may not be delving into all those ones. I think, yeah, at least those ones, noise analysis, and yeah, also temperature. Maybe it may be more important for analog IC design, but for here, just being the fundamentals we want to learn. So it's just the AC, DC, and and the transient analysis. So that's what we're going to be doing there. Then after that, we'll move to the physical design, that's layout. So for the layouts, these are the steps. So PCL based and netlist driven layouts. Yeah, all this will get clear. I'm going to explain that later. Design rule check. So after laying out, you need to follow rules actually. And these rules differ from it varies from PDGs to PDGs. Yeah, different foundries have their rules depending on the technology, so we need to follow the rules while laying our cells. So for instance, there may be rule for how much close two cells should be. Maybe you're trying to lay let's say an n-type layer. How much closer should it be to another layer somewhere, maybe the gate or something like that. All those things are to just avoid some effects, undesirable effects. So we need to follow the design rule check. Then the next thing, after you're done laying, you do your layout versus schematics. So basically you're trying to compare, okay, your layouts and that schematic you started with, are they similar? Can you take one for another? If that's the case, if you pass the test, then that means surely the layout is a good replica of the original schematics you did. Then parasitic extraction, yeah, by now you know when you're trying to when you from your device physics, you know, you're fabricating a MOSFET, right? But we usually have some capacitance effects, like you just see some parasitic capacitance, you know, some are intrinsic, some are extrinsic, like what you never intended. They are parasitic because they were not intended. That's not what you want to design, right? You just want to make a MOSFET, but as part of, you know, what you're designing, you get to have capacitances and also resistance. Yeah, I guess from the device physics you understand why you have all those things. So you get to see how much for that given layout you've done. You get to see how much of those parasitics you have, and you know, so that way you know if really what you've laid is going to work well. Then you have your post layout simulation. You come back again, you generate the netlist after you finish doing the layouts. Then you bring it back to your spice simulator. For instance, the ngSpice is a spice simulator, so you pass it there and you get to run your transient and all those things again and see if it's the same way as it was. Then you tape out. So for tape out, so for this part of the course, yeah, we're just going to be focusing on step 1, 2, 3, 4, 5, 6 and 7. Then step 8, yes, it's very ambitious for us if we can do that. So of course we can, because there are waiver shuttle programs we could join. Then you tape out your design. I think those ones especially being sponsored by Google and some other players, so we can submit there to have our IC fabricated. Yeah, so yeah, so this again, just to give you an idea of our design flow, like the flow we're going to be following for our design. So having said that, let's get started. Thank you.